The biggest mistake made in the kitchen is treating meat as just a piece of protein bought from the butcher. In reality, meat is the kinetic engineering of a living organism, and this engineering follows one absolute rule. For every second an animal moves a muscle, the fibers tighten, the connective tissue thickens, and the flavor deepens. But the meat gets tougher. Today, we are shattering steakhouse myths through the lens of science. We are revealing the big secret behind those famous cuts that most people drop a fortune on just because they are tender. Why is the most tender meat in the world actually the most flavorless? Which cut comes from where? What is its cellular structure? And most importantly, which technique is it desperately begging for? This video is your ultimate evergreen chef masterclass guide to ensuring you never waste a piece of meat again. Sharpen your knives, because we are about to break down the protein chains. Our first guest is the most expensive actor in the steakhouse lineup, the tenderloin. Anatomically, this is the psoas major muscle, sitting right tucked beneath the spine. It is a completely lazy region that bears zero load throughout the animal's life. Zero workload means zero tough muscle fibers and minimal connective tissue. The result? A tenderness score of a perfect 10 out of 10. You can crush it with a fork, no knife needed. But here is where the harsh reality of science kicks in. If a muscle doesn't work, blood flow to that region is minimal. Less blood means lower concentrations of myoglobin and minerals, resulting in a weak, inherent beef flavor. Plus, it contains almost zero intramuscular fat. That's why the tenderloin's flavor score is a mere 6 out of 10. This is why chefs don't leave a tenderloin to fend for itself in a pan. Once the internal temperature hits 54 degrees Celsius, they toss in foaming butter, fresh rosemary, and garlic, utilizing the basting technique. It absolutely demands external fat and flavor support. It's the queen for those seeking tenderness, but it falls short for flavor purists. Now, enter the true ruler of the throne, the ribeye. Located in the forequarter rib section, this is a moderately worked muscle, but its proximity to the bone grants it a massive genetic advantage: intense intramuscular marbling. The moment this meat hits high heat, these white fat webs melt, cascading through the fibers and essentially basting the meat from the inside out. Tenderness score, 8. Flavor score, a resounding 10 out of 10. This is the absolute pinnacle for achieving the Maillard reaction, that deeply caramelized, rich beef flavor, whether on a roaring grill or a heavy cast iron skillet. Moving right behind the ribeye, we reach the loin region, the striploin. It boasts a tight, homogeneous muscle structure. It isn't as heavily marbled on the inside as a ribeye, but it carries a thick, protective fat cap along the edge. Tenderness, 7.5. Flavor, 9. The secret here is to hold the steak upright with tongs before cooking the flat sides, rendering that edge fat until the bottom of the pan is coated in pure liquid beef gold. When you bite into it, it gives you that robust, full-bodied beef character that lets you know you are eating a real steak. Now let's look at the clever cuts chefs use to lower food costs while detonating flavor. First up, the top sirloin. It's the transitional zone between the loin and the round. Its tenderness is a solid 7, but its flavor score is an 8.5, easily competing with premium cuts. If you keep that thick fat cap intact and slice it thick for an open flame, you get the legendary South American picanha. It's an absolute crown jewel for building high-quality roasts on a budget. Welcome to the masters of grain, skirt and flank. These are the abdominal wall muscles, located closest to the internal organs. Because of their thick, coarse fiber structures, cooking them straight up will turn them into leather. However, their proximity to the organs means their iron, mineral, and umami concentration is off the charts. Flavor score, 9.5. Oh, kitchen science tells us exactly what to do here. First, submerge these cuts in an acidic marinade to loosen up those stubborn protein bonds. Flash sear them over blistering heat, and then execute the most critical move. Slice the meat not parallel, but completely perpendicular to the grain, against the grain, at a sharp angle. Your knife does the chewing for you, leaving behind nothing but a melting, flavor-packed fajita masterpiece. We have arrived at the greatest sorcery in culinary science, a muscle that works tirelessly all day long as the animal chews, the beef cheek. Throw this on a grill and its tenderness score is a flat 1. But if you submerge it in a rich liquid bath inside a heavy Dutch oven between 80 degrees Celsius and 95 degrees Celsius for 4 long hours, a process called braising, a miracle unfolds. The incredibly tough connective tissue surrounding the muscle fibers, collagen, denatures under the sustained heat and melts into liquid gelatin. gelatin. This gelatin transforms the meat into a succulent morsel that yields to the mere whisper of a fork. Post-cooking, tenderness, 10. Flavor, 10. This is a chef's signature restaurant showstopper. The heavily burdened legs and neck, the shank and the neck, rely entirely on this exact same collagen miracle. The neck infuses stews with that deep, nostalgic, comforting beef aroma, while the shank, as its central marrow bone leaks into the braising liquid, morphs into the celebrated Italian masterpiece, ossobuco. If you are looking for a zero-waste, lean, yet versatile muscle, that is where the peeled knuckle steps onto the stage. Sourced from the front of the hind leg, it is completely denuded of silver skin and fat. It is not meant for the steak grill, but when sliced razor-thin for high-heat stir-fries, pounded thin for schnitzels, or cubed for comforting stews, it is the ultimate wild card in a commercial kitchen. Clean flavor score, 7.5. As you can see, my friends, there is no such thing as bad meat in a kitchen, only poorly matched techniques. For a chef armed with science, tough meat doesn't exist. There are only collagen bonds waiting to be patiently unlocked. Be honest, are you still one of those people dropping fortunes on a tenderloin just because it's soft? Or have you fallen in love with the marbled architecture of a ribeye and the collagen alchemy of a beef cheek? This is the science of cooking, where we treat the kitchen not just as a workplace, but as a fascinating system of thermodynamics and molecular kinetics. To share this with your kitchen crew and to have a quick reference guide whenever you are planning a menu, save this video right now. See you in the next Culinary Science Lab. Don't forget to hit subscribe and smash that like button. Happy cooking!